দেবব্রত একটু শেয়ারটা অফ করতে পারিস 1 মিনিটের জন্য? So, okay, everyone. So I am from the academy LS2M, Let's Study School of Mathematics. So Devabroto is the tutor for this course. He is an IITian, MSc from IIT Kanpur. Then Devabroto has qualified CSI and NET with an astonishing rank of 35. So well, he is teaching this class, this batch. He is teaching basic group theory and basic real analysis. So we in this year, in 2026, we will target, say, before maybe August, to go through the basic, then the medium level, to the advanced. Okay. So 6 months is quite a lot of time. So we are planning to give around 40 classes for group theory and say around 50 classes for real analysis. So first few classes will be kept open. So please be there. There will be few more demo classes as well. Be there and let us know your feedback at least. That will be very nice. Okay. That's all. Devabroto, start. Okay. তাই আমি লিভ করলাম।
See, for real analysis, I'll follow these books. So Walter routine, basically I'll follow this book, and for metric space, this book is very interesting. Okay, so you can follow schemata for basic, but don't read it rigorously. Just follow the problems. Okay, this is also a nice book. So this class will be from basic to advanced, so don't worry. Today's class is very basic. Now I'm starting. So what is a set? A well-defined collection of distinct objects. This is called a set. So what is the meaning of well-defined? Anyone? So well-defined means there is no ambiguity. So if I say collection of good students, okay, is it a set? This is not a set, because still, what is the meaning of good student? Someone think ki good student means if a student get 80% above mark, then for his criteria, he can say he is a good student. Or someone think above 50%, if a student get a mark, then he is a good student. So there is some ambiguity, right? It depends on person, varies on person. So if there is no ambiguity, then this is called well-definedness. Okay. So a set is a collection. This is a collection of distinct objects. So the objects must be distinct. So for example, so the set notation, the capital alphabets I will use, like A, B, C, P, Q, R, X. what is the meaning of object? Members or elements are said to be the objects. Okay, and the object notation is small a, b, c. Okay, if a is a member of capital A, then it is denoted by A belongs to capital A. So here A is the set and small a is the object, is an object which belongs to the set. So this is the notation. Okay, A belongs to capital A. It means small a is a member of this set capital A. So if small a is not a member of capital A, then it is denoted by small a does not belongs to A. So if I am saying this is my set, if I am picking an element, an object A, if A is a set, then there is no ambiguity about the presence of small a. It may belongs to A or it may not belongs to A, but both cannot happen together. This is the meaning of well-definedness. Okay. Now, what is subset? Subset every element of B is a member of A. Then we say B is a subset of A. See, I have two sets. A and B are two sets. I will say B is a subset of A when if every member of B is also a member of A. So pictorially, by Venn diagram, if this is my B, this is my B set, if it is contained in A, it means B is subset of A, and this is the notation. This lecture is very basic lecture. So from basic to advanced, I will go. Or you can write like this. Okay. Equal set. Anyone wants to say what is equal set? Ishika, do you want to say?
If the elements of set A and B are like
Mhm.
all are same.
You can say like this. So basically, I have two sets A and B. When I will say A is equals to B, it means every members of A is also a member of B, and every member of B is also a member of A. It means A is subset of A and B is subset of A. If these two happens together, then I will say the two sets A and B are equal. Okay. We say A is equal to B if A is subset of B and B is subset of A. It is denoted by A is equals to B. Proper subset. What is the meaning of proper subset? Alam? If B is a subset of A, then we say B is proper subset of A if B is not equals to A. That is, I want to say B is a subset of A, but B is not equals to A. Notation is this. Some books follows this kind of notation. Okay. So what is the meaning of proper subset? It means B is contained in A. Okay. But properly. It means there exists an member small a belongs to capital A which does not belongs to B. Okay. There is a member A belongs to this set, but this A does not belongs to this set B. Okay. It is the meaning of proper subset. So from the Venn diagram, you can easily observe B is a subset of A, right? But there exists an element small a belongs to capital A, which does not belongs to capital B. Okay.
Sir, can we say similar sets are equal sets?
What?
Can we say similar sets are equal sets
No, no, no. Similar set are not equal. See,
or equivalent sets?
equivalent.
What is the difference between these terms?
See, this set, the set of all natural numbers and the set of all integers. These two sets are similar or equivalent. It means the cardinality of this set and this set are equal. So first you need to know what is the meaning of cardinality. Okay. So what is
Number
the
of elements.
definition of card number of elements? Okay. So these two sets are equivalent or these two sets are similar, but these two sets are not equal. Okay. Fine. Because you can observe natural number, the set of all natural numbers, this is a subset of the set of all integers. But -1 belongs to Z and -1 does not belongs to this set. Okay, so wait, I'll do this kind of things in the later lectures. What is the definition of power set?
Collection of all subsets of
Oh,
any set.
what is your name?
Allah
Hassan.
Hassan.
Okay, Hassan. Collection of all subsets of A is called a power set. It is denoted by this. That is, this is equals to this subset of this. Those are notations, okay? So observe one thing, power set, it is a set, right? Power set, it is itself a set, but its member is also a set. It collects the subsets of A. Okay, so this, and this, those are the notation of power set. What is empty set? It means this is a set which contains no member. So basically, this is the notation phi. Really, you can write like this phi or like this. Okay, this is called the empty set. So can you observe empty set is subset of any set, right? Empty set is a subset of any set. Now, if you want to know how this is possible, so first you need to know what is the definition of subset. Then try to prove why empty set is a subset of every set. Okay. So till now you know what is the definition of subset. So basically you need some arguments to prove this empty set is a subset of every set. So wait for it. Now I will do some operations on sets. Union of two sets. So union of two set is also a set. Okay, and this set contains the members of A as well as the member of B. Okay, so if X is an element of A union B, it means X is either an element of A or it is an element of B. So X is a member of A or this is a member of B. Okay, this is the notation. So I write this for two sets. You can do this for any arbitrary collection also. So what is the meaning of arbitrary collection? I will define it later. Okay, what is the meaning of arbitrary collection? You know what is the meaning of finite collection. Okay, now if you take three sets, it means this is the union of three sets. If you take the union of four sets, you can take, right? So this is the meaning of you can say this the union of finite collection of sets. But what is the meaning of arbitrary union? Okay, what is the meaning of arbitrary union? You can take the collection arbitrarily. It may be finite, it may be infinite, it may be, what is the meaning of infinite? It may be countable, may be uncountable. But for this kind of terminology, we need to know some definition. Okay, what is the meaning of countable? What is the meaning of uncountable? Okay, so wait. Intersection of two sets. A intersection B means X such that X belongs to A and X belongs to B. So see the Venn diagram. If this is my A set and this is my B set, so what is the meaning of intersection? It means I am collecting those elements which belongs to both the sets. Means this is my A intersection B. And if I take all the elements, then this is A union B. Arbitrary union. If A alpha, where alpha belongs to I, this is called the index set, is a collection of some sets, then this is denoted by X such that X belongs to A alpha for some alpha belongs to I. So first of all, you need to know what is the definition, what is the meaning of index set. Anyone? Can you say what is the meaning of index set, Hashan? Can you say what is the meaning of index set? Ishika, do you know what is index set?
No.
I think which can be numbered like natural numbers.
No. You can take I is equals to singleton set 1. Okay. This is also an index set. You can take I is 1, 2. This is also an index set. You can take I is -1, 0, 1. This is also an index set. You can take I is A, B, C. This is also an index set. You can take I is natural number. This is also an index set. You can take I is the set of all integers. This is also an index set. You can take I is the set of all real numbers. This is also an index set. So actually index set is a set. Okay. So why I am writing index here? Because see, if I am choosing 3 elements, if I am choosing collection of 3 elements. Okay. So actually in alphabet there are 26 alphabets, right? So if you need 27, if you need the collection of 27 sets, then you need to choose some numbers like 1, 2, dot, 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 27. So then you can represent the collection like this. This is the first A1, this is my sum set. A2, this is also some set. Similarly, A27, this is also a set. So if you need collection of 3 sets, so you can write like this: A minus 1, A0, A1. So index set is basically used for to say about how many collections are there. Is there finite number of collection? Is there just one element? Is there just two elements? So for this, for the notation, I need the index set, or for the numbering, I need the index set, or to call the set, I need index set. Okay.
It
See,
means minus
if
one is
if
just
you
notation.
GT for this A alpha, if I am saying the first set is A1, A1 may be natural number set, it may be some set, right? It may be the collection of all cats in the world. Okay, this is also a set. I can name this set is A minus 1. So if I am saying the collection is not countable, now basically what is the meaning of countable? Countable means you can count the members. You can able to count the members. For example, if you see the set of all natural numbers, you can count it. This is the first member. This is the second member. This is the third member. This is the fourth member, right? You can count it. You'll be able to count it. Similarly, if you see the set of integers, you can say this is the first member, this is the second member, this is the third member, this is the fourth member, this is the fifth member. So you can count it now. But if I am saying, can you count the set of all real numbers? The answer will be no. Why? We'll know it later. Okay. So you cannot count the members. So what is the meaning of arbitrary union? It means if you take the collection, then the collection may be countable, may be uncountable, may be finite. This kind of factors are there, right? So to know the name of the collection, name of the sets, we need some index set I. So I actually use to give the name of the set. Okay. So index set is nothing. Index set is also a set. Maybe anything. Okay. So in some books, you will observe there is some books start with chapter 0, then chapter 1. So if anyone wants to say the chapter is chapter name minus 1, you can do it. The chapter name A, you can do it. Anything. Chapter name say A1. So basically index set is used to call or uh, name the set. Okay. Hassan, is it understandable? Is it fine?
Yes, sir. Yes, sir.
Now, what is the meaning of arbitrary intersection? This is basically this set where I is the index set. Okay, where I is the index set. X such that X belongs to A alpha or all alpha belongs to I. Okay, what is the meaning of complement of a set? A complement, this is also a set which collects those members such that X does not belongs to A. So that is the meaning of A complement. Can you say what is the meaning of this? This is called De Morgan's law. De Morgan's law. Ishika, do you know?
Intersection.
Rushdi?
De Morgan's.
This is very basic. Okay, so I am not proving this kind of things. Similarly, for this, I will get this set. So if you want to prove, actually I am giving you, this is an exercise. Do it. So first you need to know what is the meaning of equality of two sets. Already I have done this. Okay. So this is a subset of this set and the converse also. Okay, say when two sets are said to be disjoint, if the intersection is empty, then we say A and B are disjoint. Now see some language, contrapositive and converse. Actually, you need to know these two terms. These two terms is very important for any pure mathematics course. Okay, so contrapositive and converse. If P and Q are two statements, then P imply Q if and only if not Q imply not P. This is called the contrapositive statement, and for the converse of P imply Q is Q imply P. Okay. Can anyone say some examples? Anyone? Hassan? Do anyone know about the differentiability and continuity? Anyone? Do you know what is differentiability? What is continuity? Okay. Anyone read group theory? Hello? Say, One example I am giving you from group theory. Cyclic. Suppose G is a group. Okay. Suppose G is a group. G is a group. Then if G is cyclic, then G is abelian. Okay. So what is my P statement? G is cyclic. And what is my Q statement? G is abelian. Okay. So observe P implies Q. So if G is cyclic, then Q holds. Then Q is abelian. Okay. So P implies Q. Now I want to know what is the converse. What is the converse? The converse means Q imply P. Okay. So it means G is abelian. It will imply G is cyclic. Now I am saying, so is the converse true? This is my question. Is the converse true? The answer will be no. Right? Those who know some group theory, they know the converse means if G is abelian, then G is cyclic. This is not true in general, right? So for counter, I have take G is equals to K4, K-lens 4 group. So this is abelian, but K4 is not cyclic, right? So observe one thing. If P imply Q, then the converse is Q imply P, but Q imply P may not be true. So if P imply Q, it does not imply Q imply P always. Okay. So first of all, is it fine? What is the meaning of the converse? Converse means if there is some implication, then the converse means the opposite implication, right? But the converse may not be true. But so see some example from real analysis.
Every Cauchy sequence is convergent.
Every Cauchy sequence is convergent. Okay, is it true? Every Cauchy sequence is convergent. See from something. So if anyone is not able to understand this example, so don't worry. This is the example from group theory. Just you need to know what is the meaning of converse. Converse means P imply Q. If this is an implication, then the converse implication is Q imply P. Okay. So observe one thing. If P imply Q is true, okay, then Q. So observe, this is true, but it may not be true. Okay. So I am also giving some examples. We'll read when we will read sequence. Then Hassan says, Hassan, what did you say?
Every Cauchy sequence is convergent.
Convergent imply Cauchy. Okay.
Yes.
If this is my P statement, then this is my Q statement. Convergent imply Cauchy. But the converse statement is what? What about the converse? The converse statement says Cauchy imply convergent. Is it true? Is it true? Always?
Yes, sir.
No. This is not true always. This is true in real number. This is true in real number, in the case of real number system. But in any general metric space, this is not true always. Okay.
Okay,
So
sir.
if you are working on real, if you seeing or doing all these things in real analysis, then this is true. But in general, this statement is not true. Okay. I think everyone knows what is the meaning of converse. Okay. Similarly, what is the meaning of contrapositive? So observe one thing, P imply Q. Contrapositive statement means contrapositive statement means
Not
not
Q.
Q imply not P. So just think about, if this is true, then this will be true. This will must be true, right? Just feel it. For example, not Q imply not P. Why? If if P holds, suppose P holds, then it will imply Q holds, right? So why I am saying not Q? So not Q imply not P. See, for this example, say I am saying cyclic imply abelian, right? Cyclic implies abelian. So not abelian implies not cyclic, right? Why? Think, if this is cyclic, then it will imply this is abelian by this statement. So why I am saying this is non-abelian? This is false. So if this statement is true, then this is also true, and the converse part also. What is the converse part? Converse
So
part means
excuse me. Suppose that contrapositive is not true. Will there be any
contrapositive is always
possible?
true.
It is always true.
Contrapositive is always true.
Okay.
Contrapositive is always true. Okay. So that I am explaining. See, if I am saying this statement is not true, okay, if I am saying this statement is not true, it means not abelian. It does not imply not cyclic. It means this is cyclic. Actually, it means this is cyclic, right? But since this statement is true, it means cyclic imply abelian. So, but I am saying not abelian, na? So if this is wrong, then how it is possible? One time I am saying this is not abelian, one time I am saying this is abelian. How this is possible?
Yes. You
Okay.
are correct.
So that's why contrapositive statement is always true. And if you take the contrapositive of this statement, then it means, if you take the contrapositive of this statement, it means not abelian, right? Means abelian. Sorry. If you want to know the contrapositive, it means not cyclic, means cyclic. This will imply not abelian, means abelian. So the converse is also true. So that's why I write P imply Q if and only if not Q implies not P. Okay? Not Q imply not P. So you can think some real life examples.
If a number is even, then it is divisible by 2.
If a number is
If a number is even, then it is divisible by 2.
you can think like this. What is your P statement? P statement is even. Number is even. Number is NO means number. Okay, this is a short notation. I will not write NUMBER. Okay, number is even. Q is divisible by 2. Divisible. The number is divisible by 2. The number is divisible by 2. So observe one thing. P imply Q. And here observe Q also imply P. Here the converse is true. Okay. If a number is divisible by 2, then the number is even. So one thing I want to say, in real analysis course or any course, the definition is always if and only if I am saying some definition, then the definition is if and only, always if and only. It means the converse is also true. Is it fine, everyone? Hello, is it fine? Loknath, is it fine? Please unmute yourself, and I'll able to know is it
Yes,
fine
sir.
or not. Okay. I'm not giving some real life examples because you can see it. Okay. This kind of things is very, very basic. So I am not discussing it. Difference. Difference of two sets. It means A, this is defined by, this is a collection of those members belongs to the set A which does not belong to the set B. If you see the Venn diagram, if this is my A and this is my B, I am taking those elements from A which does not belong to B. Okay, so if this element belongs to A, okay, but this element is also belongs to B, so I will not take these elements. Okay, this element does not belongs to A, so I will not take this element. Okay. First of all, the element belongs to the set A and it does not belong to the set B. Oh, sorry, this is my mistake. Symmetric difference. Symmetric difference is defined by like this: A difference B union B difference A. So observe the Venn diagram. It means, what is the meaning of A difference B? This, right? And what is the meaning of B difference A? This. So this part, this and this part, union of these two sets is actually the symmetric difference. So in group theory, I take power set of X, G, say this is G, and with respect to the symmetric difference operation, this will form a group, and actually this group is abelian, okay, and every non-identity element, those who knows, sorry, every non-identity element of G is self-inverse. It means if A is non-empty, actually empty set is the identity element of this group, then order of A is 2. Okay. So in group theory, this is a very important example, and Shushti, this example came in this year JAM, right? Are you there, Shushti?
Sir,
Are you there?
sir, can we write this symmetric difference equal to A union B minus A intersection B?
What do you think?
Yes, sir.
What do you think?
A union B
Nini,
minus
what
A.
do you think? What do you think? Can you write?
I think these two are equal.
Obviously, these two are equal. Okay. You can write this also. Okay. See some properties. A union B, this is equals to A union B intersection A union C. So union is distributive over intersection. Okay. Similarly, I can write this for intersection also. A intersection B union A intersection C. Okay. This is called distributive property. Do you know the Cartesian product? Do you know what is the meaning of Cartesian product? Anyone?
Pairwise multiplication of two sets.
Okay. Then A plus B is equals to this belongs to A, this belongs to B. Where, or you can write this is equals to this. Okay. So actually this is not actual definition. Okay. Because I am saying, because I am taking the Cartesian product of two sets only, then this is fine. If I am writing A1 inter A1, A2, A3, this, then you will say this is the collection of this kind of elements, right? Okay. Then I think you will say right. You will say this. Okay. So this is the notation of for all. Okay. But if I will write product of all alphas where I is any index set. I may be the set of real numbers. Then what you will write? You will not able to write the first component. Okay, think about it. So for the this is also the Cartesian product. Since I didn't know what is the first element, I didn't know what is I, this index set. Then what is the meaning of this Cartesian product? If I say I is the set of real number, then what is the meaning of the Cartesian products? So for this, actually this is very useful for topology. So then I will say what is the meaning of this Cartesian product. Okay. So till now I have no need to define this kind of things, Cartesian product of uh, actual definition. Actually, what is the actual definition of Cartesian product? Since uh, here I have no need to explain this kind of things. Actually, I need only the Cartesian product of finite number of sets. So I am writing this kind of things. Okay, you can write like this or you can write like this. Okay, so try to know what is this. Okay, Hassan.
Yes, sir.
What is my question? Try to know what is the actual definition of Cartesian product. Actually, what is the definition of Cartesian product of arbitrary sets? Suppose you didn't know what is I. So what is the definition of Cartesian product of arbitrary sets? Here I take the Cartesian product of two sets, right? Actually, this is the collection of functions. Okay, just this is an exercise. So
Is
try to
capital
run it.
pi?
Hmm? What?
What is the is it capital pi?
No. Actually, this is the product. This means this is pi. Actually, if I say product of alpha belongs to my index set is 1, 2, 3. If I am saying A alpha, it means A1 cross A2 cross A3. Okay. Okay. Now I didn't know what is my I. If my I is natural number, I am saying this. Then by seeing this, I can easily write this kind of things. But if my I is some real number, then how can I will able to write? I didn't know what is the first component, right? Can you say what is the? Can you able to find? Is it a countable set? Okay, this kind of discussion is now not relevant this time. So for more information, wait. Okay. So now I am giving some exercise. Is it equals to B? Is intersection is distributive over difference?
Sir, I think the right hand side of 4 would be A union C cross B union D.
No. What is your question?
I think the right side of 4 would be A union C
Actually,
cross B.
okay. Okay, wait.
Actually, the left hand is two elements. I mean the collection of ordered pairs. But if it would be so, then the
Okay, okay,
right hand
okay,
side is
okay.
one.
Now, okay, fine. Now this is fine. Then exercise, do it. Now, what is the definition of function? If x and y are two sets, then by a function we mean a rule which assigns a unique value in y, which assigns a unique value in y for each value in x. It is denoted by if is a function from x to y, that is f of x is equals to y. This is called the image of x under the function f is y. Okay, I'll denote like this. Here x is called the domain of f and y is called the codomain of f. Okay, and what is range f or image f? Image of f basically
Subset of codomain.
basically this is the elements of y for which y can be written as f of x for some x belongs to capital X. Okay. Now for example, see, if I am taking capital X is equals to 1 minus 1, capital Y is equals to minus 1, 0, 1. If f is a function from x to y, and I am saying x goes to x square, then what is f of 1? This is 1. What is f of minus 1? This is also 1. So this is called my codomain. This is called my domain. And what is the range of f? The range of f is the singleton set 1, right? Now, function. Now see, restriction and extension of a function. Fn means function, okay? So if x naught, this is a subset of x, and f is a function from x to y, then restriction of f to x naught, this is also a function. The function, say this is a function from x naught to y, for which f of this x naught goes to f of x naught. Okay, fine. So actually I am restricting the images only for x naught. I am taking the images for the subset x naught. Okay, so I want to say, if I am saying this is a function, if I am saying h, so h of x is equals to f of x. This is true for all x belongs to the set x naught. And what is the domain of h? The domain of h is x naught, which is a subset of capital X, and the codomain is same or maybe a subset. You can take the image set also. Okay. So now, what is the extension means? If y, then f star, this is a function from x naught to y, then a function g, from x to y is called an extension of f star to x. If f g of x naught is equals to f star, that is g of x is equals to f star of x for all x belongs to x naught. So see, this is my x naught set, this is my x set, okay, and this is my y. Now I am saying about the extension function. If this is my f star, say this is my f star, so there are lots of elements in x which does not belongs to the set x naught. So now I am defining the images of these elements which does not belongs to the set x naught. So like this, but the image of the elements of x naught. So if I am taking the images same in which is equals to the image of f star under the function f star, then this function g is said to be the extension. Okay, so for example, I am saying, say a is equals to 1 2 3 and x is equals to 1 2 3 4. Okay, y is equals to 0 1 2. So now see, this is my 0 1 2, this is my y, this is my 1 2 3, and this is 4. So see, say my f star is this. Okay, so this is my f star. F star is a function from a to y. Now I am taking a function g, say g1, say first function is I am taking g1. So g1 of x is equals to f star of x for all x belongs to a. But I need to know what is the image of 4. So take image of 4 is 1. Then g1 is said to be an extension of the function f star. If someone can choose g2 of x is equals to f star of x for all x belongs to the set A. But g2 of 4, someone can choose this is 0. Then g2 also an extension. So observe one thing, 4 has 3 choices. So actually there are 3 extension, okay, of f star. So extension is not unique, okay, but for the subset x0, the restrictions function is always unique. Okay, so say I can say f star, f star, I'll write two things here. F star is the restriction of both the functions g1 and g2. Okay, and g1 g2 are the extension functions of f star. Okay, fine. Yuvraj, is it okay? Hasan? So this kind of definitions is very important. After some time, when we will read continuous extension, this kind of things is very important. Okay, so read this kind of definitions very carefully. I will use it later. Okay, Hasan, is it okay? So don't think this
Yes.
lecture is actually, this lecture is very basic, but I will start from the basic. That's why I need to do it. I need to do this. Okay.
So what is the purpose of this?
Okay. Uh, actually, when we
As
will read, Hasan, say, what do you want to say?
I think if a function is not matlab if a function is not defined on matlab big domain, we can squeeze it to a small domain. Can we say
No,
restriction
function
map.
function means every element on the domain has an image, no? It must have an image. If you are
Suppose
saying it is a
continuity. If we
function,
suppose if
for
we talk about
continuity,
continuity,
for continuity, there are some another definition. Okay, so they can ask about the continuity if they want. They give some definition for closeness, imageness, denseness, this kind of things. Okay, so if they say, if I am saying, if do you know about the continuity? Anyone? Do you know about the continuity? So for Hassan, only for you, if I am saying if is a function from Q to R, if this function is continuous, if I am saying this function is continuous, then can I say, if suppose G is an extension of Q to R, this is also continuous? Can I say? Is it implied? I am saying G is the extension function of F. It means G of X is equals to F of X for all X belongs to Q. Now I want to know, is this function is continuous? So for
it
this
depends.
kind of say,
It depends on how we define the function.
yeah, okay. So actually for this kind of things, I need what is the definition of extension function, what is the definition of restriction functions. Okay, later I will do it, this kind of questions.
Okay, sir.
So make patience, keep patience, I'll do this kind of things. So when a function is said to be injective, then we say f is 1 or this is said to be injective 1 if f of x1 is equals to f of x2. This will imply x1 is equals to x2. Okay, that is, or you can say, if f of x1 is not equals to f of x2, or you can say the contrapositive statement. What is the contrapositive statement? It means if x1 is not equals to x2, it will imply, so not this, means x1 is not equals to x2, it will imply not f1, f of x1 is, so I can say f of x1 is not equals to f of x2. So actually this is the contrapositive statement of this statement. Okay, that is the definition of oneness. What is the definition of surjective or onto? If the range is equals to the codomain. Okay, what is the definition of bijective property? Bijectiveness. Bijective means,
1 1 on 2.
yes, that is if is both 1 and 1 2. Okay, now I am stopping the recording.